right, so to kick off, before I jump into the presentation, I heard a few of the questions, and I'm going to answer a lot of them, I hope, in the presentation. But one I'll go ahead and kind of address is the difference between macro towers and small cells. And what everybody needs to understand is they're all complementary. One doesn't replace the other doesn't replace, so from the way technology comes together, you take the macro towers that provide your wide area coverage, but then you have to build, you have to densify, and as you densify, you need to get closer to where the usage actually is. And what that comes down to is you have a certain amount of airwaves. And so the FCC licenses operators like AT&T a certain amount of airwaves, which then are split not only between, AT&T has licenses as well as the other operators. When you run out of that spectrum, there's nothing more you can do on that big tower. You have to either build another big tower, or you have to start coming down. And at some point, you built so many towers that nobody would be happy with us continuing to build these big towers, and that's where small cells come in. So you come in with the small cells at a on existing fixtures, and I'll show some pictures. They are, we do a lot of work to make sure that they blend in, that they're aesthetically pleasing, and so just make sure that we all understand, right? You still have to have those big towers so that as you're driving down 85, 75, 285, 400, whichever direction you're heading in all of the major highways we have, when you're at speed, you want to be on those macro towers so that you're delivering service on that. But as you get into the localized areas, when you get into the East Points, the College Parks, the Hayfields, and people are now moving slower, but you have a lot more usage that's happening, that's where you have to come closer to where the people are so that you have the connectivity to deliver both a low rate, high speed application. So I know I just said a whole lot to start that, but we can talk more about that if there's more questions. So we're going to talk about the evolution to 5G, and so I have a pretty broad responsibility within AT&T Labs. So we develop all of the capabilities for 5G, and this, my team is headquartered here out in Atlanta, but I have people across the country that work on this technology. Everything from the infrastructure that we put on the ground on these poles, small cells, macro cells that we talk about, right down to the phone that you carry in your hand, or other devices and sensors that will make up smart cities and other types of capabilities. So all of that is developed in my team. In addition, we talked about the fiber initiatives, the equipment that goes on, that fiber to deliver broadband speeds. That also happens to be developed out of my team as a secondary. But they start to come together, right? Converged access perspective. As we bury that fiber, we want to bury that fiber and serve many different capabilities, whether it be a wired connection to the home or whether it be a wireless connection. And so a lot of work that happens. But today we're going to talk about the evolution to 5G. And the key here is, the key word is blending into the urban landscape. We get it, that if you build a lot of small cells and they look like that macro tower, if I start putting that type of equipment down on light poles, I'm going to get stopped in a hurry, right? I get it, my engineers get it, we understand. So we do a lot of work to make sure that as we develop the next generation of technology, we're developing it where it blends in the environment that we're trying to build. A lot of people think about 5G in terms of a singular event. 5G is not a singular event, right? It's an evolution. It happens to continuously build on top of capabilities that are already built. So a lot of the capabilities that we've already put in with the work that we've done over the last few years actually builds and starts the foundation of what 5G will become. And so 5G, it will provide the next generation. It provides higher speeds. It provides lower latencies. We're building those capabilities. When we build small cells today, the infrastructure that we're putting on the ground is in fact upgradable to 5G. Now, there's new frequencies that will come in not to get too technical, but you have what we call our sub-6 frequencies, which propagate and go through walls and buildings to be able to connect you inside. And then you have millimeter wave spectrum, which is a very high frequency, but very short wavelength. And the shorter the wavelength, the more it bounces. It doesn't go through walls. In fact, whether or not it's spring or fall matters, right? From the leaves being on the trees or not impacts how that signal will bounce, how it will go. However, with that spectrum, it's a much wider channel of spectrum. And with that wider channel of spectrum, we can get massive amounts of data through that wireless system to where your wired connection starts, or your wireless connection starts to look like the wired connection. So you can have in your pocket on your cell phone capabilities that today are only possible when you're at home, when you're in your office. And so if we think about the evolution of technology from the G's, right? Not too many years ago, people travel, business travelers, I travel the world, I do a lot of international activities. You used to have to carry multiple things, a calculator, an alarm clock, a pager.
Actually, there were only two people at NASA that were up in space. They actually got pagers to paper, and they told them they're sorry if they can't help them. They're on their own.
They're on their own. That's right.
No connectivity.
No connectivity. So today, right, all of those things, we carry them in our pocket, right? What we carry as cell phones in our pocket were more powerful than the computer I used in college. It's incredible. So the data, Stima mentioned, the data on our network has increased 360,000%. Think about that, 360,000%. It's my team's job to figure out how we carry this mass increase in traffic. And that comes from applying more spectrum. So we've certainly spent a lot of money buying spectrum. We've built a lot of macro towers to provide that decent wide area coverage. But now we're to the point where you have to come and densify to get into the small cells. If you think about the greater speeds, think about things today. By the way, more than half of that traffic on our network today is video. I like to tell people all the time, because when we talk about 5G, it really is only limited by your imagination. When we launched 4G 8 years ago, right? It didn't matter which operator we talk about. 4G was only launched in this country 4 years ago. People said, nobody is going to watch video on that tiny little screen. Why are you building this LTE network? Nobody's going to do it. I can tell you more than half of the traffic on our network today is video. So apparently we were wrong. So there's a lot of very smart people that go and say, and we'll maybe give you some ideas of what we could do. But the one thing I want you to leave today with, we haven't even scratched the surface. Until we enable it, until you start putting the capabilities, we really don't know what tomorrow will bring. What we know is once you put the innovation on the ground, people will innovate. People will develop. It'll become very, very, very promising. So today, I said we build from here. We're already putting a lot of LTE advanced capabilities in the network. And in fact, there's pockets right here in the metro Atlanta area that have the capability of getting up to a peak speed of 1 gigabit per second today. And we haven't actually turned on the first 5G radio. We will do so later this year. So we have the capability within the technology that we're already deploying with an LTE waveform to get up to a gigabit speed today, and we take that even further as we introduce 5G. You may ask, okay, isn't a gig enough? Well, a peak speed of a gig is good if there's only one user trying to get a gig. I can't really see how many people are in the room, but let's just say there's 20 or so people in the room. If all of you want a gig, I better do something else, because you need to be able to peak higher so that your averages are all up there to where you can get that decent performance. And so it's a direct correlation of how many people are trying to do what. If we think today, 4K video, how many people have watched 4K video? There's not a lot of 4K video on the market today, so actually a good population here has seen it. It's just now starting to take off. Anybody seen 8K video? It's incredible. It is incredible. You know, people say 4K video is, wow, look at all of the, you know, watching sports on 4K video. The day's coming where 4K video, we're going to say, we watched that? 8K video. The resolution in 8K video, when I talk about live sports, it's something that will come. It's not tomorrow, but it will come. And when it comes, you're going to have those higher bandwidths. You're going to have those lower latencies. So, you know, y'all are municipalities. Obviously, as AT&T, we're going to benefit by providing higher speeds to our customers. So what's in it for you? Well, again, it comes down to massive connectivity, higher speeds, lower latency. It transforms how people consume. It's no longer just about your smartphone. It's no longer just about your tablet, your computer that you want to connect. It's about connecting many things. Let's imagine a few things. Do you have their imagination caps on? So imagine, who here deals with traffic planning? Anybody deal with traffic planning? I know I sat in one heck of a traffic jam this morning. I wish some of this technology were there. Imagine a day where we had intelligent traffic switching that could adapt the signals to actually the traffic. And if we have people with phones in their network or their car, the connected car, if you start interfacing all of these things and you start connecting them to your traffic grid, you now can actually improve the traffic flow. So by having this mass number of things that are connected, by deploying the technology that allows that, it's no longer just about providing an efficient service to your constituents. Actually can improve their lives by cutting off a few minutes of their commute. Imagine Atlanta parking. Anybody have a hard time finding parking downtown? Yes. Today we put it in the address of the building that we want to get to. We get there, we look around, that parking lot's full, that one's full, where the heck am I going to park? Imagine a day where we no longer put in an address. When we put in the address, it directs the car right to the parking spot that's open. So if you put in smart city type of capabilities where you can manage the parking and you connect that to where you have an autonomous driving car, that you can actually take the car and put it right in the spot that's open. Anybody dealt with augmented reality, virtual reality? Anybody played with those glasses? How many people after 10 minutes say, oh my goodness, I got to take them off, I got a headache? Most. Why? It's because of the latency. You're today, using today's technology, the speed. So when we talk about increasing speed, right, people can get that. They understand, hey, what a megabit is, what a gigabit is. Latency, when you think about it in the terms of virtual or augmented reality, think about the pace at which your eye refreshes. The point at which your eye is refreshing on the image. The reason you get a headache is because your eye is refreshing faster than the image is. So if you have lower latencies, and you can get the latency down below, the magic number is about 20 milliseconds. 5G, we can get it well below 20 milliseconds. And so now when you get those latencies lower, now forget about these big goggles that you couldn't walk down the street if you wanted to. They become truly glasses that you wear. And now with augmented reality, your constituents can walk down and you can have information that's produced. The city can actually embed, safety information, about information about the city, bus stops, restaurant ratings, taxi ratings, historic markers, weather forecast. What do you want to tell your constituents? If you're connected and you have these capabilities as they walk down the street, now they can see augmented reality, but now you start to, give them information on top of that. You can communicate that way. Here's my favorite. I do a lot of travel. How many of you miss kids' sporting events? Imagine live streaming your kids' sporting events to myself or extended family. You can watch it live. Today we do a good job with phones. We can record it and we can see it later. There's something about seeing it live and then being able to talk to your kid about it right after the event, not they told you all about it and then you saw it. Intelligent ambulance. Anybody had the misfortune of a loved one injured, call the ambulance. Imagine the doctor being able to be connected to exactly what's going on in the back of that ambulance and directing the care en route. Or first responders themselves, monitoring the surrounding environments and conditions, environmental and hazard data being updated real time. These are just a few, right? These are things that people can think about today based on the capability. But again, we haven't even begun. And vendors and innovators, they'll start to imagine when the capabilities start to get built, and will continuously build on top of that. It really does introduce what we call the Industrial Revolution. So I promise I'm not going to get real technical. All these big words. Anybody here know what 256 QAM is? No? Okay.
Of course we did.
Oh, well, let me talk to you. What I will tell you is the technology evolves. You have different modulation schemes, you have different frequencies. And what this basically chart tells you is that with LTE, what we call LTE Pro capabilities, which is the latest and greatest advanced technology, we already start introducing capabilities that get us to a gig. Again, we talk about those really short airwaves, the 5G millimeter wave spectrum. And now, instead of having carriers, from an LTE perspective, just to put into a little bit of perspective, the maximum channel size, frequency perspective for LTE is 20 megahertz. When we go to millimeter wave, the minimum channel size is 100. And they can go to 200, 400, and 800. And so I go from a channel, right? So think about a highway system. If your highway, think about a one-way street. LTE is a one-way street. With millimeter wave, you just opened up the massive highway, the downtown connector, all of the lanes, right? So you go from a little lane to a very wide lane, and you can shove a lot more things through it. We talked about, there's licensed spectrum, there's unlicensed spectrum, and so all of these different spectrum things, what it really matters is what are the licenses, what are the capabilities that I can deploy, and that ultimately dictates, is it a macro tower or a small cell? When you get into the unlicensed territory, you get into the millimeter wave territory, the power levels that they radiate are so low that they only work when you get into small cells, and that starts to open up larger amounts of spectrum, which allows us to serve so much more. Well, I love the radio because, well, that's what I've done for 20-some years. It's more than that. We've got all of our core connectivity. We've got all of our SDN NFV efforts. So at AT&T, we've been building to this day for the last 3 years. From a foundation perspective, we get multi-gigabit speeds, high capacity. We get connectionless massive IoT, ultra-low latency, high reliability, sub-6 millimeter wave unlicensed, massive MIMO, SDN, NFV. What does that really mean? It means there's a lot of smart people who work that bring it all together to make this little thing that we carry in our pocket and in this pocket. Maybe I have probably a few more pockets with a few more phones, but you get the point. All of this comes together to deliver seamless, fast, real-time services. Now if we get to kind of the point of the macro tower and the surrounding small cells. Again, it all works together. If you can see on this left-hand side, we have the big tower, then you have lots of little towers behind it. Think about an umbrella. You have an umbrella that serves many users, wide area. But think about the drops of rain that sometimes blows in this way, that way, right? And it's not covering the whole area. Well, if you apply that to small cells, you have the umbrella, and then you bring lots of small cells in to make sure that you're taking care of the areas that umbrella is not serving. So if it's coming from the side where it's dripping through, you got a hole. The small cells basically help you fill in those gaps. We have multiple technologies, and I'll show some pictures here in a minute, that all come together on a pole. By the way, this is the cellular technology, but when we start talking about smart cities and sensors and things that go on the poles, smart lighting, there's so much more we can do on the pole. We can integrate and make them aesthetically cool. So these are all real deployments. I don't see one from, how many here have been to Centennial Park? How many here have seen small cells in Centennial Park? So I think I saw 3 hands that have actually seen them, and I saw just about every hand come up. There's not a pole in Centennial Park that doesn't have a small cell, guys. They all do. People don't realize it. I tell people all the time, driving to my office, they say, oh, when's the small cell build going to happen? Well, you pass 6 of them between 85 and my office, and it's only a mile. Right? So people don't see them when they're built right. The key is when they're built right. We, as an industry, have got to partner with municipalities to make sure that we build them right. In Centennial Park, they're all painted green. All of those poles are green. They're painted green. There's a circle. When you look at them, so I'm going to tell you, when you go, you can look a little closer. At the top of all of those light poles in Centennial Park, there's a little circle. Frankly, it's just a facade. It's just to make uniformity. But there's a little circular piece that's on every one of those poles. And the majority of them actually have small cell antennas that are behind that circular piece. And so there's a lot of ways where you just build it in a uniform way that people walk by and they don't even realize it. It's there. So these are all, again, real examples from just having an antenna cap that's at the top. The one to the right has the antenna cap and electronics that are at the top. The one here in the second from the left has a cap antenna with a couple of radios. A lot of times you see those radios behind signs. You got traffic signs all over the place. If they're on light poles and traffic signs are on there, you just put the equipment behind the sign. You don't even know they're there. And then here on the wood pole one, this is probably one of the largest ones, and that's the larger piece of equipment there is not actually even saleable. It's so you look at other utility type of boxes that are there, and when you that people see today, and then you put another antenna on the top of it, it all just does blend. I mentioned concealment alternatives, but again, I'm going to mention no one size fits all. Every environment is not the same, and what we're trying to build on all of them aren't the same. You have small cells, you have the antenna. NR, we're going to talk a little bit about what 5G NR, and there's some challenges we have to worry about with millimeter wave, but we can even get creative there. But then we talk about smart cities and all these sensors, right? What are you trying to do? What all are you trying to light up? Do you want smart lighting? Do you want just connectivity? Do you want digital signage? Gunshot detection? Vehicle charging, smart waste, video cameras, you name it. All of these different things can come together aesthetically on a single pole. One may say, oh my goodness, the pole's going to be cluttered, it's going to have all these things. Maybe, but maybe not. You can conceal the street furniture, you can conceal in the pole. So there's a lot of different ways. If you look on the left-hand side, this is a deployment that we've done. Basically has a pole-top concealment shroud with an antenna, with ancillary equipment up there. The radios, this is one where, in fact, that was before the signs, I think, got put back on it. But the reason I put this up is millimeter wave. When we go to 5G, we have to be careful when we start writing some of the rules for the municipalities. There's a lot of times that we see people say, hey, we want to put everything in a shroud. 5G will not work in a shroud. Millimeter wave will not work in a shroud. So in this case, we've developed a concept where effectively we do a donut. So right at the top of the pole, without getting into the technical details, but from a millimeter wave, because of the waveform, if you put any type of concealment in front of it, you basically block the signal before it did anything. So that just doesn't work. But you can go in and fool the eye by putting these antennas around the pole and then put fillers to make it look like it's just a circular donut. That one's a concept. The first units being developed by our partners that meet that only become available next year as we start to ramp up our 5G millimeter wave. We'll be using concepts like that to make them aesthetically blend into the environment. And so in this case, what I really want to show here is that picture that I showed with all of those different options. This pole actually has every single thing that was on that previous page on it. Now granted, there's some things that are kind of called out, but it has everything from the cellular capabilities. It has a police call box. It has digital signage. It has upgraded light fixtures. That has just about everything that was on there, and it all just starts to blend. And so, there are ways. We just have to have a conversation of what is it that we're trying to do, and then make sure that all the partners for all the things you're trying to do work together to make sure that aesthetically it blends. So, just in closing, the value prop. We have to. We as a mobile operator, we have to provide an aesthetic modular form factor that simplifies multi-technology and multi-organization deployments. While AT&T is in smart cities and we're in the cell business and we're in all of these different things and we'd love to be the provider of all of these things, we recognize that's not always going to be the case. We have to build modular systems where multiple parties can come together in an aesthetically pleasing way. From cities and municipalities, we know we have to partner. We know that the aesthetics have to be there. We know that it has to support multiple technologies, and it has to be a simplified, efficient deployment. You don't want your city streets blocked for days building a site. By the way, small cells get built typically in an hour, 2 hours. When you have everything together, you can build it quick. From an LTE 5G perspective, we have to have forward-looking design. My team has been working on 5G designs for 3 years. We've been building the pieces so that what we build today allows us to have the building blocks that we can come back and simply add the next piece that gives us the next greatest capabilities. We have to have synergies with smart city electronics so that we can use common infrastructure like backhaul, power, real estate. And then of course for the smart cities, solutions, multiple cities have different requirements. They want to do different things, right? It's what's important to one municipality in the smart city space may not be equal in all cities. So you have to be ready for that. When you bring them together, one of the biggest challenges of connecting multiple devices in smart cities is in fact the fiber power real estate. Well, guess what? If you have to have the same capabilities, leverage them both. And then ultimately drive collaborative planning across smart city densification and 5G.
I have a question.
Yes, ma'am.
In the middle, it says forward-thinking design for 5G.
Yeah.
What is the next big thing?
Millimeter wave. So when we build most of our small cell deployments that well, all of them that we're building this year, and definitely going next year, the electronics that we're putting on those poles today is the same electronics that we need for 5G that will allow us to then just come back and put a millimeter wave radio. And so everything else is already there. We have one more component that we put on it, and now you just, and with the same assets, you've just taken that small slice of spectrum, which is relatively a small pipe, and have been able to expand it 10, 20-fold by just a little box that gets added. Yes, sir.
Two questions. What's the typical range you're seeing on the small cell technology you have currently? And is a lot of, obviously, the small cells probably working off of each other, so are you seeing a lot of line of sight as well?
Yeah, so on the current technology, it operates in what we call the sub-6 frequency. Sub-6, you don't have to have line of sight at all. It in fact is built for non-line of sight. It depends on the build, depends on how high. There's a lot of factors, but typically we have 500 meters roughly. We have some that get closer to a kilometer. It just depends on the height, but most of them are what we call below the clutter, which really is isolated. It's trying to contain the signal to where the usage is. And when you do that, you want to actually come line the city streets, the urban canyons, bring it lower so that you can serve. You put the signal where the users are.
The second question was, we're trying to hit a speed for everybody. What are the speeds? How high do you see the speeds that
So with the capabilities that are available on the sub-6 that we've deployed so far, the highest I've seen is 979 kilobits per second, so just under, or megabits per second, just under a gig. And that's a peak, right? It's not sustained. It peaks up to that, which is the theoretical limit, by the way. With millimeter wave, some of the early trials that we've done, and millimeter wave, we're doing a lot to get away from point to point. It is a little bit more point to point. But what ends up happening, frankly, in the design of the device, you just put more antennas within it to where, with millimeter wave, it bounces. The signal bounces a lot more. So it's not necessarily line of sight. It'll just, you may think that from me to you I should have coverage and I may not, but from me to her, because the signal bounces, I do, right? And so you start to engineer for the bounces, which is very different. Sub-6, you don't want it to bounce. You want it to, you want to contain it and know where it's going to go. With millimeter wave, you want to maximize the bounces.
you usually have both those running simultaneously to get all of that covered?
Yes. And so that's when you start thinking about building millimeter wave, especially for mobile services, you want to anchor it on sub-6, so that'll always give you connectivity. And then you have what we call a secondary carrier, which is this white pipe that as soon as it sees it, it bursts. And yeah, and it provides you. I don't want to quote the highest number we've seen because they've probably seen higher, but we've seen multiple gigabytes or multiple gig peak speeds with millimeter wave, and a lot of that has to do with the infancy of the electronics.
Yeah, sure. The devices get better, they will accept it better as well.
Well, the early devices limit how much bandwidth, how much spectrum you can apply at one time. When you get to the full maximum that's possible, that it's not inconceivable that you can get up to 10 gig plus. So it's your backhaul, the fiber connectivity of putting all those things together will likely be your limit just because of the trade-offs in cost.
Right. Well, they should.
It's coming. We're starting, actually, the city of Atlanta has been named as one of our first 5G markets to launch this year. If we don't, all right, somebody else might be speaking next time. That might be my top objective this year. Yes, ma'am.
I have a quick question for you. Okay, so you guys are building the infrastructure, everything's rolling along, but you said your team has been working on this for 3 years. So what kind of key learnings have you guys kind of, amassed in terms of what works, what doesn't work? We talked about the wave technology and the certain things that you kind of have to do in order to kind of lay the foundation so that as you're deploying the network, things are going to work and you can add other things. I just had several questions. I'm just writing this stuff down. Sorry, so I'm kind of rambling a little. But Question number one, key learnings, from a business perspective, I'm a small business, what did you guys learn from them as you kind of did trials to kind of determine what was of value to them? How did that differ from an enterprise customer as an Intel, and I think Ericsson you guys did some things with, so can you kind of talk to that a little?
Yeah, so first of the key learning, just from a raw technology perspective, one of the things we had to learn was our engineers, when we go design a system, they've always engineered it based on the sub-6 frequencies. And you really do have to think differently with millimeter wave. And so learning how to predict that you're going to have a balance is important, right? So if we're trying to develop a coverage layer and have impact surety that I'm going to reliably be able to have a good enough signal for you to reliably get those higher speeds, I've got to be able to predict when it's going to bounce, so that and where it's going to bounce, so that I can maintain that signal. Now the interesting thing is, and the reason that it takes so long is we had to do a lot of this testing through the year. We did testing in many environments across the country, but ice, rain, leaves on trees, leaves not on trees, all of that matters. And starting to build that institutional knowledge to where we can engineer and predict is where we've got a lot of the learnings from a raw technology perspective. From an application perspective, what we learned was that frankly we could serve a lot of the applications that enterprises, consumers, and small business, I'll come back to small business specifically in a minute, that a lot of the applications that these consumers want to use, that they're accustomed to using from a wired connection, works just as effectively on a wireless connection when you have those high bandwidth applications. So those were two. Now when you think about small business tends to mimic consumers. Tina showed a chart early in her presentation about the number of people that have cut the cord. Small business cuts the cord a lot more. And so having reliable, one of the biggest things that we hear out of our small business team is being able to provide reliable connectivity that a small business can use wherever they are. Because a lot of small businesses, whether it's, we see if they do have a shop, maybe they move their shop. Guess what? Being able to pick up your shop and move it over here and it still work the same way, and you don't have to call AT&T to come set everything up again. That's something. A lot of small businesses, their phone, their business phone is their lifeline, right? Having that work, by the way, wherever you are, being able to connect, and just as if you were in the office. And so we see a lot of that for small business, and very similar for consumers. They want to basically cut the cord, and everything they used to be able to do with a fiber-based connection, they can now do with a wireless connection. Did I get all your questions?
You did, and then I have one more, I'm sorry. So, a lot of your competitors have talked about, they've got these 5G phones that are coming out. So what's AT&T kind of bringing to the table as it relates to a 5G capable phone?
Yeah, absolutely. So look, everybody's got their own pitch on all of these things, and so I'll talk about what I know about all. So Verizon's going to launch fixed wireless. They're going to launch it with a pre-standard. By the way, after AT&T said we're going to start with mobile, Verizon came back and said, we're going to do mobile too. Little hidden secret, whatever Verizon does pre-standards with anything they do with fixed with pre-standards, when they go to the standard-based solution, they actually got to go take the device, it's a fixed CPE, they actually have to take that back and give you a new one to work on the system that is standards-based. So we'll see what they do. Frankly, they're going to build 4 markets. They've publicly stated they're going to launch those this year. It'll work. We've been testing the same pre-standard system for a couple of years ourselves. It works. It just doesn't have a lot of legs going forward. Right? So we opted to wait for the standards, and we're going to go with standards right out of the gate. And we'll be the first mobile deployment of 5G based on standards at the end of this year. We'll start with a puck, basically small business, Wi-Fi puck. Effectively, you can connect multiple devices, whether via Wi-Fi. Believe it or not, Wi-Fi is the limiting factor, not the cellular connection, which is
the big pivot that happens when you introduce 5G. T-Mobile says, hey, we're going to be first to nationwide. Stay tuned. We'll see about that. That's about all they can say. By the way, they say they're going to launch 30 markets this year. I own the network side, the device side. I'm not sure what device they think they're launching this year with that, because there isn't one that works on their frequency. Okay? And in fact, there isn't going to be one for a long time into 19. So there's a lot of noise coming out of T-Mobile, but when you understand all of the pieces that it takes to launch the service, and if you don't have a device, it doesn't matter. Okay? And then Sprint. Sprint has said they're going to launch the first smartphone. Okay, maybe. I don't think they'll be out that much faster, but they're going to launch a smartphone. I'm not sure how many places you can use that smartphone because they have very small pockets of coverage. And so again, everybody is talking about firsts, but the reality is you got to look at the whole picture and what does first mean and how does that come together. And so I feel pretty good about our strategy. We'll start with millimeter wave because that's the devices that come first. When devices that can support, without boring you with the details of the differences in frequencies, but when devices can support the frequencies that allow us to do wide area coverage, I would be willing to bet we'll have a pretty good wide area coverage ready to go as well. Yes, ma'am.
So coming back to the
Mhm.
what is this going to mean in terms of cost to the end user with all of these new potential applications?
Yeah, so I'm the technology guy, so, but I'll just talk to you about historic trends. What I can definitively state is the cost per bit, so as an end user, every time you hit a button, whether in the app or, it's using bits. And your data usage is going up. What I can definitively state is your cost per bit, cost for the amount of, has not been going up, it's been going down. And so certainly as we open up more pipes, if you start to use more services that drives that up, then yeah, your cost might go up, but it's not going to go up at a rate, right? It's your cost per bit will likely continue to go down, but if you do more and you start to use the devices in many different ways, your price for that, your cost for that might go up, but you may eliminate 3 other things, and so your overall cost likely is equal and the same, but or even lower. But I'm not the pricing guy. Just to be clear, I'm the technologist, but you just look at historic trends. The cost per widget has been on a decline for years. He's been holding his hand up there, and I'll come right back to you.
No problem. So to me, cloud is sort of, 5G is sort of analogous to cloud. So we were super excited about it, and we knew that it had the potential to change the way we do business and even live. But it wasn't until we had sort of critical tenants like Amazon, Salesforce.com, that we started to see acceleration of adoption of the cloud. And I think there was no really connected movement between sort of cloud providers and application providers. As we think about 5G, are you guys partnering with application providers to ease that path?
Yeah, so let's talk. As an important point that you made. One of the challenges for the cloud to take off is in fact connectivity to the cloud, right? And so we can put a lot of things in the cloud, but if you don't have a solid connection with enough bandwidth to make it work, then putting the application in the cloud is not going to work. And so as you start to increase your bandwidth and lower your latencies, you'll see more and more things go to the cloud. What you'll also see is the cloud start. Today, clouds are typically in national data centers. You see some already today where they're doing more regional. Greengrass is one. Right? They start to do more regional deployments. And so as you start to push the cloud further to the edge, you now can get, if you've got a fast connection with a low latency, from an application on the device, you can actually have a very lightweight application on the device, which by the way helps battery life, and have it do all your heavy computation up in the cloud. And you can go, trigger it, and come back just as quick as today you can run an application on the device. And so to answer your question of partnership with application providers, we do this actually every day already today. I see it accelerating. I see more of it as you start to get the connectivity that allows more things to connect, right? And by the way, a lot of those things have to be lightweight, long battery life, which will push more of the computation up into the cloud. So they're very interrelated. We're very bullish on the cloud moving further to the edge, and because we think that's what will accelerate the adoption.
Yes, I was just curious, how does visualize that as back up with other metro areas across the country in terms of demand, access to applications like that, through this situation, a lot of the times to
Yeah, what I would say is Atlanta is it's in the top 10. Getting more precise than that would probably be speaking a little bit out of school. But if I go and just look at our traffic amounts, Atlanta's in the top 10. Certainly, if you think about Manhattan, the financial district, in San Francisco, they drive higher amounts. But once you get out, Chicago, American Mile, you've got pockets in some of these other cities. But once you get out of those, Atlanta stacks up very well. The broader metro area stacks up very well with what we see across most cities in the U.S. Other questions? Yes, sir.
I've got a question. I don't know if I missed out on this. We've had AT&T in our subdivision in South Fulton for a while now, and I love the applications, but it seems like it's always going down. Is it the infrastructure that we need to upgrade, or the technology is great when it works, but when it doesn't work, it's horrible. When it starts raining, everybody comes to my room. I have a $20 antenna, and we can watch everything because everything else is down for a minute. So it's always going down. So is that an AT&T thing, or is that
the wired connection?
I mean, it's everything. I mean, it goes out like 2 to 3 times, probably on a daily basis. It comes right back up. But
it's your home connection you're referring to, not a cellular connection. Is it your do you have a broadband connection?
Well, yeah, UVerse. Yeah, UVerse, and even I mean, but it's on the south side. Everybody, it's. So I'm just wondering, is it the infrastructure, or how will we address something like that?
Yeah.
He can give me his phone number and I'll run it.
Yeah, we'd have to look to see exactly what's happening. There's a million things that could be happening. We've got to have somebody go look at it. But if you give Diane your address, we can get that looked at.
And we are doing a lot of upgrades. I am your contact information, but I get the notices when they're about a fiber upgrade originally in the south. There are.
Yeah. Yes, sir.
I was curious, I was just trying cell coverage for all areas.
Yes.
New house, like, it's
The
crazy.
metro area having coverage, because I was like, I have no service.
Yeah. Well,
That's a very broad question.
it's a very broad question, and I laugh because I had to deal with a situation where somebody misappropriately spoke and said that this new technology was suddenly going to change coverage. The fact of the matter is the propagation characteristics are driven by the spectrum, right? And so when you get into rural America, it frankly comes down to a return on investment, right? We do cover all of the major highways, but covering every side road becomes more and more complicated. So sometimes T covers it better than the others, and very transparently, sometimes they do better than us. With that said, AT&T was awarded FirstNet, which for those that don't know, it's the National First Responder Network. And so we have tremendous commitments to improve and enhance our rural coverage as part of that FirstNet program. And the beauty to our AT&T customers is we can use the same airwaves to serve our AT&T customers when not when there's not a demand for public safety. When we're building the towers, it's frankly not that much more expensive to go ahead and, if we own other spectrum, we'll go ahead and put the other spectrum there as well. So we expect our rural coverage will improve first, actually on LTE, but as we upgrade, truth be told, if I'm hanging equipment today, is 5G ready? So when I build that rural, I may light it up with the current generation of technology just because, frankly, in rural America, they're typically a little slower to adopt the latest and greatest phones that can connect to it. So we have to put the legacy technology first, but it will allow for a faster upgrade to 5G. So, first and foremost, the tower has to be there. If the tower's there, the path to 5G using the macro towers with our existing frequencies is there too. It'll be a follower. Yes, sir.
Where do you see the residential roadmap for fixed location 5G going, especially since your company also has a large fiber footprint as well?
So you're talking more about fixed wireless applications? So for us, the beauty of AT&T having both a fiber franchise as well as a wireless franchise is we can choose what's best from an economics perspective to serve the location. And so if we have and by the way, every one of those towers requires fiber. And so if I'm having to build a lot of fiber to build the towers, and those are running right along the locations where the houses are, I'm better off going ahead and connecting with fiber. However, if that what we call the last mile connectivity is cost prohibitive to run the fiber, I can actually terminate the fiber into cellular equipment and deliver that last mile from a fixed wireless perspective. And so when you get more out to the rural areas, in fact, Georgia is one of our initial markets where we have been deploying fixed wireless service. So it's not really in the metro area, but when you get further in South Georgia, there's some areas. We're introducing greater technology that will allow it to come closer to the fringe areas where fiber's not passing every home, but we'll start to have wireless connectivity there. And then with millimeter wave, it starts in the cities and moves out. And so we're coming from both ends to improve connectivity to as many people as we can at the highest speeds we can. So a lot of work going on there as well. All right. Any other questions? All right.
Well, Ray, let's have a big round of applause.